Okay, so this is just a very basic flow chart of testing null and research hypotheses. So one of the comments I just want to make here is your null hypothesis is basically, Andy talks about it being a baseline. It's it is what is accepted until your data illustrate otherwise. So in this flow chart here, you've got your hypotheses that are generated, and they're testables. You've got an alternative hypothesis. So your research hypothesis, experimental hypothesis, all that is the same thing. And then you've got your null hypothesis. And so you decide up front in your research what your significance level is that you are going to be testing at. You pick your sample, you calculate your sample size, you randomly sample, so you get your group of people, values, and then through the statistical analysis, you compute your probabilities. So Andy talks a little bit about you don't ever reject or accept the null hypothesis, which is generally the terms that we use. And we're probably going to use those terms, but just so you know that it's based on probabilities. So you might have a p-value of less than 0.05 in your analysis. And then ultimately you're saying there's less than a 5% likelihood that this result is due to chance. All right, so in other words, something caused this result to happen. So you compute your probability value, and you compare it to whatever you chose you were going to test at, in this case 0.05. Again, that's not a magic number. You can test at different levels, but there's arguments for or against those levels. And if your p is less than your 0.05, you reject the null. If it's greater than 0.05, then you accept the null. So that's the basic procedure of here's my hypothesis statement, my research hypothesis, my null hypothesis. I get my sample, I run my data, and I interpret the research or null hypothesis relative to that outcome.